So the following Zoom session is being recorded and will appear later today on my YouTube channel, Math with Mayo. There are two different classes that may be observing this session. Therefore, when you participate in the Zoom meeting, if you do not wish for your picture or your name to be made public, please leave the video off and use an alias name. If you have questions during the meeting but do not wish to speak, email me at bmail@ybcc.edu and I will respond as soon as I can. Alrighty, so some things I want to remind you of, just in case you've forgotten. I don't use Canvas, and I don't look at messages sent through WebAssign. So again, if you want to get in touch with me, you want to know your grade, you want an extension, you want to know what I had for lunch, whatever, email me at the address that's in front of you there, bmail@ybcc.edu. Also, if you haven't already, please print out and read the syllabus. Just to let you know expectations, if you look at the schedule on the syllabus, it tells the schedule for every day all quarter. It tells what days certain material will be presented and what day at what time it's no longer available. I want to point out a couple of things if you haven't been in college before, but an hour class meeting in class usually can be expected to have up to 2 hours of homework. This is summer school. So we cover 50 days of material in 28 days. So basically, the hour-and-a-half meeting we're going to have each day will be covering 2 normal days of material, okay? 2 sections. So it's not unusual to expect to have between 3 and 4 hours of homework a day, okay? Just to let you know that. All right, now, another thing that people do that is a mistake, if you look at the syllabus, you'll see that, for instance, today's homework, Mondays, we're going to cover 2 sections. We're going to cover section 3.7 and section 4.5. Now, the due date says tomorrow at 11:59 p.m. If you wait until tomorrow at 10 p.m. to start your homework, you're not going to get it finished. In fact, you shouldn't even be waiting till tomorrow. Just because it's due by tomorrow night, technically, it's due by tomorrow's class. The reason for that is this. If you have questions over tonight's homework, then you can ask it tomorrow during the office hour or during class time. If you wait until tomorrow night to start today's homework, you're going to be out of luck getting questions answered, okay? Because I don't sit here monitoring my email 24/7. All right. Any questions about that before we continue? Okay, now, can somebody tell me, just to verify, can you see on your screen, on the right side, it says today we will be covering section 3.7 and 4.5, and on the left side of the screen, you see a grid that is actually WebAssign. Can somebody just verify that I've clicked on all the right buttons? Great.
Yes.
Because I've been known to click the wrong thing and I'll talk for 10 minutes and then somebody will say, oh, we can't see what you're doing. So let me know if something like that goes on. All right. Okay, so let's get down to blank screen. What I want to start with is I want to review the process of how you would graph a linear equation. So let's say we have the linear equation. Okay, here we go. Y equals, let's say, 1/3 x plus 2. Okay. Now, there are several different ways we can graph this. One is to use slope-intercept form. One is to use intercepts. One is to just pick a couple of random points. I'm going to go with picking a couple of random points, and then if people want other methods explained, I will be happy to do that. But what I'm going to do right now is I'm going to find 2 ordered pairs that are solutions to this equation. Tell you what, let's start out with, let's find the y-intercept. So we'd set x equal to 0. So then we'd get y equals 1/3 times 0 plus 2, which is 0 plus 2, which is just 2. So the y-intercept is at 0, 2. Any questions about how I did that? All right, let's find another point. Let's take x equals 1 and solve for y. So we get y equals 1/3 times 1 plus 2, y equals 1/3 plus 2. 1/3 plus 2 would be 2 1/3. Okay. Any questions about that? So now I'm going to go over to the WebAssign screen, and I'm going to go through the process that you need to use. Now, if you ignore these instructions and you try and just do it your own way, good luck, okay? Because you've got to do things a certain way to get success. If you do them differently, it may work, it may not. So again, please follow these instructions. First of all, what are we trying to do? We're trying to graph a linear equation, a straight line. So over on the left, I'm going to choose the square that has lines, not the circle or the parabola, as we'll learn later, or single points. We're looking to graph a line. Now, when I click on this, there are three options. This first one is a line. Notice it has arrows on both ends. This second option is what's called a ray. It has a point at one end and an arrow at another end. And the third option is called a line segment. It has given endpoints. We are trying to graph a line. So if you choose either of these other two, it's not going to be correct. All right, so I'm going to click on the solid line until it turns blue. Okay, now the next thing I'm going to do is I'm going to plot these 2 points over here. So notice my scale, each square is 1 unit. So 0, 2 is right there. And 1, 2 1/3, let's see, x is 1, y is 2 1/3 is right about there. Oh, it didn't plot things where I wanted it to. It plotted that second point at 1, 2. So how can I fix that? So I'm going to go over here and I'm going to click on line 1, and notice it has 2 ordered pairs. The first one is 0, 2, and the second one is 1, 2. So what I can do is I can go in and I can correct the value from 2 to 2 1/3. Okay, so here, let's put in 2 1/3. The problem is you can't use a mixed number in this screen. So what it thinks I've done is said 21/3, which is 7. So that's not correct. So how can I put 2 1/3 into that screen? What I have to do is I have to take 2 1/3 and change it into an improper fraction. So that's going to be 7/3. So over here, I'm going to use 7/3, and here I'm going to use 7/3. Any question about anything that I did there? All right.
Question.
Yes.
Sorry, I had it on mute. Could I also use it? Could I also do decimal or no? Or it has to be.
The problem is 7/3 as a decimal would be 2.3 repeating. So if you put in 2.3, it would be wrong. If you put in 2.33, it would be wrong. If you put in 2.33333333, it would be wrong because it needs to be 2.3 repeating. So unless it is an exact decimal, let's say we had 2.5 and you put in 2.5, unless it's a decimal that can be written exactly, then you would want to avoid a decimal. Okay, does that make sense?
Okay, yes.
Yeah. There is a way to put in a repeating decimal. I don't remember how to do it. It's a little tricky. I would say just don't. Go with improper fractions or exact decimals when necessary. Okay, now, so what I've done is I've graphed this equation, y equals 1/3 x plus 2. Notice again, I found 2 ordered pairs, not 7 pairs, just 2 points. I clicked on this specific line, then I put the 2 points in there, and there I have my solution. Okay, now I want to go back over here, and let's see here, I'll get my eraser, And we're going to do this. We're going to erase that and erase this. Okay. This was what, 7/3. We're going to change this to y is greater than 1/3 x plus 2. So now what we're going to be doing is we're going to be graphing what is called a linear inequality. So we're not graphing the line y equals 1/3 x plus 2. We're graphing y is greater than 1/3 x plus 2. Okay, now how do I go about graphing this thing? Well, the first, whoops, why did that disappear? Okay, that was interesting. The first thing we're going to do is we're going to take the inequality and we're going to rewrite it as an equation. Okay, so now I'm basically back to what I started with before. I'm going to find two ordered pairs, and here they are. All right. In fact, let's go ahead and let's clear all this and let's start over. So now I'm going to come in and I'm going to say, oh, I've got 2 points, 0, 2, and 1 7/3, which again, did I have to come in here and change this to 1, 7/3? So basically that's everything I just did before. Only now consider this. This is not what we're trying to graph. I just used that equation to establish the location of a couple of points. I want to graph y is greater than that. So it does not include the y equals that. So what I need to do is I'm going to go back over here to my line and I'm going to change it to a dashed line. When you're graphing, let's say on a number line, okay, and you've got this number line and you've got some points, 0, 1, 2, and you're including a point, oops, 0, 1, 2, you're including a point, you either have a full circle or maybe use a bracket depending on which method you're using. If you're not including a point, you use an open circle or parentheses. Remember that from graphing on a number line? Well, what we're doing here, we're not graphing y equals 1/3 x plus 2. We want everything that's greater than 1/3 x plus 2, but not including it. So what does that mean? That means that we've got this dotted line. It establishes a boundary. We now need to figure out y greater than that. Would that be above or below the line? It's going to be what we call a half plane. It's everything above or everything below the line. Now, to figure that out, we're going to use what we're going to call a test point. And we're going to use 0, 0 in this case. I can use any point I want as a test point as long as it's not on the solid, or in this case, the dashed line. 0, 0 is always a great point to use as long as the line doesn't pass through it. So 0, 0. So what I'm going to do is I'm going to take this inequality and I'm going to put in a test point, 0, 0. Okay, so that's going to give me, putting it in here, I'm going to get 0 greater than 1/3 times 0 plus 2. So we have 0 greater than 0 plus 2, 0 greater than 2. Is that true? Is 0 greater than 2?
No.
No, it's not. So that means that my test point, 0, 0.
I can't see that equation on my screen. My screen ran out, so I can't see that part of the equation. I can only see the left part of what you're writing down.
Okay, are you using your phone or a computer?
A computer. I have it on.
How about now? Can you see it now?
No, I can't see anything that you just put in that box on the right side. I can't see. I can only see test POIN. I can't see anything to the right of that.
Can you see it now?
No.
I couldn't see it either because of the reason that it had our faces on the side. So all I did was just move it to the side.
Oh yeah, yeah. Is it? Yeah, you might need to move the part of the screen that has your faces on it.
Okay, how do you do that? Sorry,
Okay, so
I apologize.
that not a problem. Hey, we're figuring this out together. That's okay. So you've got this block of faces, right?
Yeah.
Okay. One of the things you can do is click on, well, look at the one that has my picture on it.
Uh-huh.
Do you see where it has some options where there's a bunch of dots, like there's 9 of them, and then there's 2 of them, and then there's 1 of them? You see that?
Yeah. Yeah.
Okay. Click on the one that just has a single, yeah, it has a single dot, and see if that makes it smaller.
Yeah.
Does that help?
Okay. Yes, it does.
So
Thank
now
you.
can you see everything?
Yes.
The other thing you can also do is if you kind of hover your mouse above where those different options are and click on not one of those different options, but sort of to the right or left of it and hold it, you should be able to move it around on the screen.
Okay.
Can you do that?
Thank you very much.
You bet. So can everybody see what I'm doing now?
Yes.
Okay,
Yes.
great. Yeah, any issues you're having, please speak up, okay? Don't just let things go by. Let me know. Stop the show, okay? Not a problem. My goal here is to help you learn this stuff, not to confuse you, okay? All right. Now, let's see, where were we? Okay, we had this test point, 0, 0, which would be over here. See where my mouse is over on the WebAssign screen? But it said it didn't work. It was false. In fact, I was getting ready to write, oops. Getting ready to write false. So what that means is 0, 0 is not part of the solution, which means that everything below the dotted or dashed line is not part of the solution. Therefore, we can conclude that the solution is above the line. So I'm going to come over here to fill and click on that. So my solution is everything above, but not including the dashed line. Okay. So it's kind of like, this is my property. This is the neighbor's property. Here's the property boundary. He put up a fence, but it's his fence. So the fence establishes where my property ends, but it's not my property. Okay. So the solution is everything above, but not including that dashed line. Are we okay with that?
Yes.
All right, now we're going to go back over here and we're going to change things a little bit. Okay. We're going to look at, oops, this scenario where it says y is greater than or equal to 1/3 x plus 2. Okay. Again, in fact, let's go back here and let's clear all this because we're going to start over. So again, I'm going to look at the related equation. I'm going to come up with a couple of points. So I'm going to come over here and I'm going to graph 0, 2, and 1, 7/2. Again, I'm going to have to fix this. And I know I've done all this before, but I want to just kind of reinforce the process. Okay. But now we're including everything greater than or equal to 1/3 x plus 2. Well, the y equals 1/3 x plus 2 would be a solid line. So it's no longer dashed. It includes that. But it's also y is greater than. So again, I'd use this test point and find out it's false. So now my solution is is everything above and including the solid line. So now it's my property and it's my fence. The neighbor doesn't own the fence. It's my fence. It not only establishes the boundary, but it's my fence. Okay?
Is that still considered a linear inequality then?
Yes, it is. Because if it just has the equal, it's a linear equation. But if it has greater than or less than or greater than or equal to or less than or equal to, those are all considered linear inequalities. Yes, good question.
Okay.
All right. Any questions on this example? Go ahead, what?
I have a question.
Yeah.
I have a question. So if the point falls within the shaded area,
it's a straight line, not dotted?
No, 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 no. What makes it a solid line is if it includes equal to.
Okay.
Were you talking about if the test point?
Yes.
Yeah, no, the test point has nothing to do with whether it's a solid or dotted line. The test point tells us which side of that line is the solution set. Okay,
Okay, so how do we know when it's supposed to be dotted and when it's not supposed to be dotted?
okay. If it says just greater than or just less than, but it doesn't have equal to, it's going to be dotted. If it includes greater than or equal to or less than or equal to, so if it includes the equal to part, it's going to be solid line. Okay,
Oh, okay, that makes sense.
Yeah.
Thank you.
you bet. And we're going to look at some more examples here. All right, so let's go ahead and clear all this. And we'll look at another example. Okay, let's see here. This says 5x plus 4y is less than or equal to 20. All right. So this is an inequality, but it also includes the equal to. The first thing I'm going to do is create the related equation. Okay. I'm going to use this to plot my points. So I'm going to make a table and I'm going to find two ordered pairs. I'm going to go ahead and use the intercepts this time. So to find the y-intercept, I'll set x equal to 0. To find the x-intercept, I'll set y equal to 0. Remember, x and y intercepts where the graph cuts through the x-axis or the y-axis. So let's complete those ordered pairs. Let's take the case where x is 0. So we have 5 times 0 plus 4y equals 20, which is 0 plus 4y equals 20, or 4y equals 20. Divide by 4, y equals 5. So there's 1 point on the graph. Okay. Now let's find the x-intercept by setting y equal to 0. 5x plus 4 times 0 equals 20. 5x plus 0 equals 20. 5x equals 20. Divide by 5 and x equals 4. Again, and if you find me going too fast, let me know. I can slow down. Also recall that I'm recording all of this, so you can, if you miss something and you want to come back to it later, you can always go to the YouTube channel and take it at whatever pace you want. Okay. All right. Anyway, so now we've got 2 points right here. So let's go over here. Our goal is to graph a linear inequality. So I'm going to click on this until it's a solid blue. I'm going to graph the point 0, 5 and 4, 0. Okay. I'm going to check to make sure 0, 5, 4, 0. Now, my inequality includes equal to. So my solution is going to include a solid line. Okay. Because it includes equal to. Now, I need to figure out which side of that line is also included in the solution. So again, I'm going to use 0, 0 as a test point. Okay, so test point 0, 0. So I'm going to plug that in here. 5 times 0 plus 4 times 0 less than or equal to 20. 0 plus 0 less than or equal to 20. 0 less than or equal to 20. What about that? Is that true? Is 0 less than or equal to 20? Anybody?
Yes.
Okay. I get so lonely when there's no one else there. Okay. And that's fine. So So that means that 0, 0 is part of the solution. So now I'm going to fill in the side of the line, or the side besides the line, that is including 0, 0. So there is the solution. It's everything below and including the line 5x plus 4y equals 20. All right with this?
Mhm.
Okay, let's see here. All right, let's take a look at another example. So we'll clear this and we'll take a look at, let's see here. How about this one? 3x minus 3y greater than or equal to negative 10. Okay. So I'm going to be graphing a linear inequality. I can already see that it includes equals. So the line I'm going to graph is going to be solid, and then I'm going to pick one side or the other of it. But I'm going to look at the related equation, 3x minus 3y equals negative 10. I'm going to use that to get my points. Okay. And again, I'm going to go ahead and use the X and Y intercepts. You don't have to do that. They're just nice points to find. So if y is 0, we get 3x minus 3 times 0 equals negative 10. 3x minus 0 equals negative 10. 3x equals negative 10. So x equals negative 10 thirds. Okay. Second ordered pair, set x equal to 0. 3 times 0 minus 3y equals negative 10. 0 minus 3y equals negative 10. 0 minus 3y is negative 3y. So negative 3y equals negative 10. Divide both sides by negative 3y equals 10 thirds. Okay, so I'm going to come over here and click on the line. I want the solid line. Let's see, negative 10 thirds 0. Well, negative 10 thirds is about, well, it's negative 10, what? Negative 10 thirds would be negative 3 1/3. So that's somewhere about over here. Oh, look, it didn't go where I wanted to. Don't panic. And then 0 10 thirds would be about there. But thank goodness I can come over here and I can put in anything I want there. So negative 10 thirds, 0, and then 0, 10 thirds. I'm not always going to get horrible values, but I'm wanting to show those to just so that you don't panic if you can't figure out how to plot a value like that. You got to go in here and correct it. Okay, now it includes equal to, so it includes the solid line. We don't know which side of the line we're on yet. So again, I'm going to use 0, 0 as a test point. So here's my test point. 0, 0. I'm going to put that into the original actual inequality that I'm trying to graph. 3 times 0 minus 3 times 0 greater than or equal to negative 10. 0 minus 0, 0 greater than or equal to negative 10. Is 0 greater than or equal to negative 10? Yes. So 0, 0 is a solution. So I'm going to fill it on that side. Okay. Any questions on that?
No.
Now, if I was actually doing my homework, when I got done with this, I would click on submit answer. But if I did that right now, it would say it's wrong because I'm using this problem, but I'm doing different equations. Okay. In fact, tell you what, let's do this actual problem to see what the whole process. Okay. So x plus y less than 2. All right. So I'm going to look at the equation x plus y equals 2. Okay. I'm going to find what x and y intercepts. So we get x plus 0 equals 2, x equals 2. 0 plus y equals 2, y equals 2. Okay. So now I'm going to go over here and click that till it's blue. 2, 0, 0, 2. Okay. But notice it does not include the equal sign. So I'm going to have a dashed line. And also my ordered pairs are correct there because they were nice ones. Okay. So now I've got a graph on one side of that line or another, above it or below it. And again, I'm going to use 0, 0. That just seems to be a nice test point. So test point 0, 0. I'm going to put that into my original statement. Okay, so now again, I've got my original inequality. I just look at the equation to find the points to plot. But then for my test point, I go back and plug it into the original. Okay, so I've got 0 plus 0 less than 2, 0 less than 2. This is true. So that means I'm going to fill in on below. Okay, so if I've done everything correctly, when I go over here and put submit answer, it should come back and tell me, yay, see, it's got a green arrow there. Okay, now a question that came up the other day from students, and I want to remind you, this is on your test taking policy that you all read and then agreed to. If you go back and look at it, it should tell you, I believe, that on your homework, you get an unlimited amount of chances. So if you get it wrong, you can go back and do it over. On your tests, you just get one chance. So you want to make sure things are right. But let me go back here for a minute and let me show you what happens if I put in the wrong information. Okay, let's see, there, we'll go there, and we'll make that a dashed line, and we'll fill in there. Okay, so here, I've submitted that as the solution to this. Now I go submit answer, and it says, uh-oh, it's wrong. Okay, so if you get a red X, that means your solution's wrong. Go back and figure out what's correct. If you get a green check mark, you've done everything correct. Any questions about that? Okay, so we're going to go back and look at some more examples. Let's see here. How about this one? Y is less than 3x. Okay, so we're going to graph this linear inequality. We're going to start out by looking at its related equation. Okay. And let's go ahead and find X and Y intercepts again, since that seems to be working just fine so far. Well, let's see. If Y is 0, I get 0 equals 3x. Divide both sides by 3 and you get X equals 0. Well, if X equals 0 when Y is 0, then if I try and complete that second ordered pair, I'm going to just get 0, 0 again. So I'm going to have to choose something different for X now. So how about, let's see here if I can access my eraser, and we'll just erase that and come back here. How about if we use 1? So if X is 1, Y equals 3 times 1, Y equals 3. Okay, so I've got two ordered pairs, 0, 0, 1, 3. My point being, if you pick some values and you can't get two different points, pick a different value. Okay, so now we're going to go over here and we're going to use 0, 0 and 1, 3. Okay, let's see, 0, 0 and 1, 3. Oh, it says less than, so I'm going to use a dashed line. All right. Well, I've got another problem. Since this dashed line goes through the origin, I can't use the origin as a test point. I'm going to have to use something else. Okay. So test point. As long as I don't pick something on the line, how about let's pick 3, 2 right here, 3, 2. Okay. So that's going to go in here. So y2 less than 3 times 3, because this is X and Y, 2 less than 9. Is 2 less than 9 true? Yes, it is. It's true. So 3, 2 right there is a correct solution. So I'm going to fill it on that side. So there's my answer. Now, again, if I clicked on submit answer, it would not say it's correct because this is a different problem. I'm just using the screen to demonstrate the problem. Okay? Any questions about that one?
No.
All right, let's take a look at another example. How about this one? Y is greater than -3. Well, let's look at the related equation, which would be y equals -3. Recall from graphing in the past, whether it was last quarter or 20 years ago, who knows? Y equals a constant is the graph of an equation that is a horizontal line. So this is going to be a horizontal line passing through y equals -3. Okay. So let's tell you what, let's go ahead and find some points for it. We could let x equal 0, and let's see, if x is 0, we get y equals -3, don't we? Because x isn't even in the equation. Well, now, if I put y equals, oh, wait a minute, I can't put y equals 0 in there because it says x equals -3, okay? Excuse me, it says y equals -3. So in this case, x could be anything it wanted to be. And y is going to be -3, -4.2, y is going to be -3. So no matter what x is, y equals -3. So how does that look? Well, we're going to have a horizontal line. Here's 0, -3, and here's what? 7, -3. Okay, so there's our horizontal line. But wait, it said y is greater than -3. Okay, y is greater than -3. So it doesn't include it. So that line is going to be dashed. Okay. Now, let me ask you this. Y is greater than -3. On this graph, where is that? Is that above -3 or below -3? Y is greater than -3. Would that be above -3 or below -3?
That would be above.
It would be above. But in case you're kind of going, what just happened? Let's use a test point of 0, 0. So we put that in here and we get 0 greater than -3, right? Because we can't put x anywhere. If 0 is greater than -3, that's true. So our test point is up there. Okay with that?
Yeah.
Question? I couldn't hear you.
You just said yes.
Okay, sorry. Okay, I want to look at one more example, and then we're going to take a 5-minute break, and then we'll go on and look at section 4.5. So we're going to clear that, and we're going to look at, let's see here, x greater than or equal to -4. Okay. So let's look at the related equation, which would be x equals -4. Now, we just got done with an example that had y greater than -3, but we said y equals -3 was a horizontal line. Well, x equals a constant is a vertical line. Okay, so it's a vertical line passing through x equals -4. Well, again, let's find some values here, and we can't do that because remember, x is -4. So basically, when x is -4, what's y? It could be anything it wants to be, right? Because if we picked y, let's say y is 5. Well, 5, you can't put y into the equation because there's no y in it, so it's going to be x is -4. If y is 0, x is -4. If y is -2, X is -4. If Y is star, X is -4. If Y is whatever, X is -4, okay? So over here, we've got X is -4, Y is 5. X is -4, Y is 0. What do we get? We get a vertical line. All points on a vertical line have the same X value. Now, what does this say? It says X is greater than or equal to -4. So is the line going to be solid or dotted?
Solid.
Solid, because it includes the equal part. Okay. What about X is greater than -4? Where over here would X be greater than -4? Would it be to the left or to the right?
To the right.
Yeah. For instance, this point right here, what's the X value? Right there. What's the X value?
5.
5. How about this point right here? What's the X value?
5.
X
2.
value, 2.
I mean 2, sorry.
Now, every point over here is going to have an X value greater than -4. And again, you could put in a test point if you want to and plug it in, and you'd see that. So there's the solution. Okay. So just a couple things I want to remind you of. X equals a constant is a vertical line. Y equals a constant is a horizontal line. If the inequality includes the equal to, it's going to be a solid line, and then you're going to shade on one side or the other. If it doesn't include it, so there's no equal to, it's just less than or greater than, it's going to be a dashed line, and then you're going to shade on one side of it or the other. Okay. So what I'm going to do right now, I'm going to stop the sharing, and I'm going to stop the recording.